The building collapsed. It was brought down.
The Joint Direct Attack Munition is a technology that transformed the entire military world. It's one of those disruptive technologies that allows entire governments to save billions, if not trillions, of dollars when it comes to carrying out precision strikes or simply conducting bombings in enemy territories. It's a kit weighing about 267 kilograms, which allows a large and heavy metal object, in this case a bomb, to hit a shopping cart here on the ground with relative precision, considering that such a bomb was dropped from 13 kilometers high or 45,000 feet. Even considering that it's nighttime, it could be raining or snowing. Statistically speaking, during World War II, the large and heavy bombers dropped 40 to 60 bombs each. Only 20% of those bombs landed within 300 meters of the target. Roughly speaking, the bombers of that time dropped, on average, 600 to 800 bombs, so that only one would fall within a radius of less than 10 meters from the target. This terrible rate of inaccuracy in the attacks caused major and severe side effects, such as many civilian deaths, destruction of unwanted infrastructure, and sometimes even the escape of intended targets since the attack failed. To overcome these problems of inaccuracy, in the late 1950s, engineers looked to the laser as a solution, with the concept of using the laser to guide bombs instead of using it as a weapon by itself. The laser-guided bomb concept emerged. A laser-guided bomb is a type of precision bomb that uses laser guidance to steer itself and hit the target accurately. In this type of bomb, the target is illuminated by a laser that is not visible to the naked eye, typically in the infrared spectrum. This laser can be emitted by the aircraft that dropped the bomb, by other planes or helicopters, or by ground forces. On board the bomb, an optical seeker head located at the front identifies and locks onto this laser beam, and the bomb starts making corrections to its trajectory until it hits the target. The only problem is that fog, clouds, and adverse weather conditions greatly affect their ability to stay locked onto the laser beam, consequently impacting the accuracy of these bombs. In addition, dust kicked up by other nearby explosions could obscure the illuminated target and also affect accuracy. And it was to overcome all these limitations that engineers looked for another solution that could work under any conditions. And that's how, in the late 80s, the Joint Direct Attack Munition program, or simply Joint Direct Attack Munition, was started. However, at that time, the Global Positioning System was still experimental and not fully developed. And the idea of using satellite navigation for real-time bomb guidance was considered radical and controversial. However, the engineers went ahead anyway. The Joint Direct Attack Munition is a guidance kit that converts an unguided bomb, known as a dumb bomb, into a precision-guided bomb. More importantly, it works in any weather and temperature. It's a kit made up of a tail section with aerodynamic surfaces that move, a metal strap that is attached around the body of the bomb, and a combined inertial guidance system and a global positioning system guidance control unit. Once the kit is attached to the bomb and the bomb is attached to one of the pods on the fighter jet's wing, the Joint Direct Attack Munition is almost ready to be used. Once in flight, the Joint Direct Attack Munition's navigation systems are initialized by transferring data such as position vectors and current speed from the fighter jet's systems. Once the bomb is released, the Joint Direct Attack Munition navigates and guides itself autonomously to the designated target coordinates. The exact target coordinates can be loaded into the aircraft before takeoff or manually changed by the crew in flight before the bomb is released, or entered via a data link from onboard targeting equipment, such as the Lightning II or sniper targeting pods. During its descent, the Joint Direct Attack munition makes several adjustments and trajectory corrections until it impacts the designated target. In its most accurate mode, the Joint Direct Attack munition system will provide a circular error probable or circular error probable with a minimum accuracy of 5 meters or less when a global positioning system signal is available. If global positioning system is jammed or lost, the Joint Direct Attack munition can still achieve a circular error probable of 30 meters or less for free fall times up to 100 seconds. This means that when the global positioning system signal is available at the location, the margin of error for a bomb equipped with the Joint Direct Attack munition system is only 5 meters or less from the target. This level of accuracy is maintained even if it's raining, snowing, there are dense clouds of dust caused by other explosions, or other adverse conditions. Since global positioning system-based flight control systems know the current location of the bomb and the location of the target, these bombs can autonomously adjust their trajectory to hit the target, even if the aircraft launching it is at angles far off the target's axis, and even if the target is slightly behind the aircraft at the time of launch. Initially designed by McDonnell Douglas, the JDAMs began testing in 1993, and the testing phase lasted until 1999. During this phase, more than 450 bombs were dropped, achieving an incredible accuracy rate of 95%. During this phase, the Joint Direct Attack munition was dropped through clouds, in the middle of storms, in the rain, and in the snow. However, the accuracy was not affected under any of these conditions, maintaining a circular error probable that ranged from 5 to 10 meters from the target. The B-2 Spirit, the most expensive airplane in the world, was the aircraft that debuted the JDAMs in a real war environment in 1999 against the Federal Republic of Yugoslavia, in a flight that lasted more than 30 uninterrupted hours. During this attack, the B-2 Spirit dropped a total of 651 JDAMs with an overall hit rate of 87% on the designated targets. JDAMs have 3 major advantages, the first being the ability to maintain the same accuracy regardless of the conditions at the location. The second advantage is an expanded launch acceptance region, or launch acceptance region, which defines the area where the aircraft must be to release the bomb and still hit the target. With laser-guided bombs, for example, at the time of release, the aircraft needs to be in a position where the bomb seeker head can see the target. This forces the aircraft to always release the bomb with the target exactly somewhere in front. And this doesn't happen with JDAMs since they use global positioning system coordinates. The third advantage is the true fire and forget capability, where the weapon doesn't require any support after launch. This allows the launching aircraft to immediately leave the area and proceed to its next mission after release. Another important advantage provided by global positioning system-based guidance is the ability to hit targets at certain specific pre-established angles. This allows JDAMs to strike targets exactly vertically, meaning top-down impacts for greater penetration, or to hit targets from the side in order to create specific damage or collapses. However, if JDAMs require the exact coordinates of the target to be entered into their systems before launch, this means they cannot be used against moving targets, such as cars or other vehicles. And it was to overcome this weakness that Joint Direct Attack munition sheaths underwent a major upgrade in which a seeker head was added to the Joint Direct Attack munition kit, which is placed right at the front of the bomb. In this configuration, The kit is called Laser Joint Direct Attack Munition, with the L standing for laser, which allows the bomb to hit moving targets. In the initial phase of this system, 12 bombs of 230 kilos each were tested, with all of them successfully hitting very fast-moving targets. A joint direct attack munition drop from high altitudes can reach up to 27-28 kilometers. Initially made by McDonnell Douglas, the Joint Direct Attack Munition Kit is currently produced by Boeing Defense, Space and Security. And the Joint Direct Attack Munition Kit can be used on a variety of bombs, including the Mark 83 and the Mark 84, the Penetrator Bomb Live Unit 109, among others. JDMs are almost always at potential risk of having interference in the global positioning system signal they depend on to guide themselves. That's because, according to a report from the Royal United Service Institute, the Russian R-330 ZHZTEL, a communication station for electronic warfare jamming, had successfully managed to interfere with the global positioning system signal that JDAMs depend on, especially because the global positioning system signal becomes relatively weak after traveling more than 20,200 kilometers from the satellite to Earth. To deal with this vulnerability, the United States military launched a Selective Availability Anti-Spoofing module. Also includes a global positioning system signal with military encryption. Ensure the Joint Direct Attack Munition only accepts properly encrypted signals and rejects all others. And since the military world is full of surprises, an extended version was also developed, called the Joint Direct Attack Munition Extended Range, in which wings were added to the Joint Direct Attack Munition Kit. These wings let the bomb glide up to 3 times farther than its original range of 27 kilometers. It can now reach targets up to 80 kilometers away after being dropped from the plane. However, accuracy remains the same. This upgrade increases the cost of the Joint Direct Attack Munition Kit by $10,000, and it was created for the 500-pound bombs and the 2,000-pound bombs. A powered version, developed by Boeing called the Powered Joint Direct Attack Munition, is also being studied. In addition to the wings, a propulsion module is added, increasing the range by up to 10 times, making it a low-cost missile. The Joint Direct Attack Munition Kit is an extremely cheap and easy-to-install technology, considering the significant advantages it offers. Turning an unguided bomb, which could fall anywhere, into a high-precision guided bomb. A Joint Direct Attack Munition Kit currently costs about $22,000 to $25,000 per unit. This cost does not include the bomb itself, the detonation fuse, and some other components. However, this cost can reach up to $84,000, depending on the size of the bomb and other components. This is an extremely low price, especially when compared to other missiles, like the Tomahawk, which costs between $1,800,000 and $2 million per unit, and the air-to-ground missile 114, Hellfire 2, used on the Mark 9 Reaper drone, which costs $150,000.